Here we go. So fun, right? Screens inside of screens. Okay, hey, look at this. We're going to be making our basic animation. This is a bit of a review for people who have, we had a Pro D Day and missed some time, so we're going to, and we're going to just get this basic animation going on. What we have are these circles that we're going to make into hills, and the idea is we want them to look like they're forever going across the screen. It looks like there's just infinite circles going across, but it's actually just 3 circles, and we're using variables to move them, and we're using if statements to make them teleport. Once they get off the screen on the right-hand side, we use an if statement to teleport them back to the other side of the screen, and we got this kind of juggling of always making those 3 circles kind of moving forward. So we'll take a look at it. I'll just go through the code that's in my project, and hopefully that'll be a good reminder for people. If this is the first time you're seeing it, it might be a little bit surprising, but taking a look at that other video that's on the website, the first look at animation video, that'll be a good thing to take a look at. All right. Oop, that's my bunny. Hold on. Here we go. So first of all, I don't think I told anybody about this. You can actually make color variables. Did we talk about this? It's not really important, but I like to use the words like green and D green for dark green and yellow. So instead of saying fill and using a hashtag, this is not important at all. You don't need to do this, but just a quick interesting fact. You can make a variable, since we're making variables anyways, with the names of colors and store a hashtag or hex color code inside of it. So if you do this, and this is, again, at the top of the sketch is always where you store your variables or declare your variables. If you do that, then you can do things like this. Watch, I'd say background blue. Anywhere where you'd expect a color, now you can use those color variables. Fill white. Fill green. It's kind of nice. It just kind of makes it a little bit more intuitive. But you do have to do this extra step. So you can decide if you want to do that or not. You can still use fill and use 3 numbers. You can use fill, use 1 number. You can use fill and use a hashtag code. Or here's another alternative. But more interestingly, I have myself some int variables. In order to make animations work, in order for things to move around on the screen, you're going to have variables to represent their coordinates. And since my circles here, my hills, they're moving horizontally, their x coordinates need to change throughout the course of this sketch. And that means I need a variable for each of those circles' x coordinates. I'm lazily calling them x1, x2, and x3. So it's the x coordinate of the first, the second, and the third hill. We'll get back to their initial values in a minute, but you want to kind of spread them out. And notice that they are 400 apart. The difference between negative 200 and 200, the difference between 200 and 600 is 400 apart, because I'm making my circles 400 wide. And that's why am I making it 400 wide? Because my sketch is 800 pixels wide. So I want kind of 2 to fit on the screen at a certain point. So I just kind of divided my screen width in half. Nothing special about 400, just half of my width is a story. And then, of course, we have our void setup and void draw. So check out that video about what those things mean. But we'll need to use void draw in order to make an animation loop, where this will be kind of being called over and over and over again. The draw function, we put all this code inside of it, and that's what happens each frame, over and over and over again. So we draw blue. And then, I'm not going to do the cloud. And then we fill green. And then we draw our 3 circles. Here's our 3 circles. x1, and then 400 is just the y coordinate, and it's 400 by 400 wide. Here's x2, here's x3, here's, I guess that's all. Those are our 3 mountains. So that's why we see 3 different circles in 3 different places, because x1, x2, and x3 started as different numbers. So at the beginning of the sketch, it's effectively saying, this is minus 200, this is 200, and this is 600. But we make them variables so we can change them. If that was actually my numbers, like they're just locked in there, they're just stuck. Hey, how come we can only see 2 circles, by the way? I'm doing 3 ellipses. Why is there only, oh, sorry, I lost it. Yeah, what's going on? Why is there only 3 circles, even though I'm drawing, or why is there only 2 circles, even though I'm drawing 3? What's the story with that? Which 2 do we see? Are we seeing on this screen here, are we seeing circle 1, 2, or 3? Pick 2 of them. 1, 2, or 3. 2 and 3. That's right. We're seeing 2 and 3. You got it. This is the one that is here, and the one on the right is this one over here. So where's the other one? Where's this one? Where's the first one? It's off the screen. It is actually somewhere on this side. It is over here waiting to come onto the screen to take the place of these other two. So that's the illusion, to create the idea that we have like endless like hills that are rolling forward. We have to have sort of a third mountain that's waiting in the wings to come onto the screen and replace it. So if you are making 4 mountains, like for the foreground, we have to have a 5th mountain waiting off the wings to come in and take its place. So if you can fit 4 in there, you need 5 altogether. If you can fit 10 in there, you need 11. You always need one waiting in the wings to come on and take the place of the other one. And that's sort of how we're making that illusion work. So, of course, these numbers are no good. We want to use the variables so we can change them. We can increase them. We can't increase negative 200. It's always going to be negative 200. But if we set x1 to negative 200, and we set x2 to 200, and we set x3 to 600, as we did up here at the very beginning. Then we got no problems about changing those values, because variables vary. That's why they're called variables. Here's me changing them. That's where I'm drawing the ellipses. Later on, down below, here we go. I'll just move the if statements. We'll talk about that in a second. This is us moving those mountains. That's why they're moving at that certain speed, is because I'm adding 2. If I added 3, they'd move faster. If I added by 1, they'd move slower. And so I just chose 2 for no particular reason, but I guess that's a fine speed for them to go at. So there they are. They're moving each frame. This is not an equation, just so you know. This is an assignment. So you couldn't really, if you treated that as an equation, it wouldn't really work, right? Like what number plus itself, what number plus 2 equals itself? That doesn't make sense. Like 5 plus 2 does not equal 5. That's not an equation. So a single equal sign is an assignment. We're saying, hey, x1, whatever you were, we're going to assign you the value of whatever you were plus 2. So this statement here is saying increase x1 by 2, and increase x2 by 2, and increase x3 by 2. So that's why they move. So if you watch them roll across, the reason they're moving is because we're constantly adding 2 to them. Now, the final step was getting them to teleport. And I'll just turn off the teleportation here. You'll get a sneak peek, and you'll see the if statement, and you might be a little bit uncertain about that. There we go. I'll turn that off for a second. If all we had was just increasing the values of x1, 2, and 3, then they would come on the screen, and they'd just keep on going. Bye, ellipses. See you later. They're never coming back. They're going to Mr. Harris's room. They're like in the window right now. And they're going. They're going to hit the lamp pretty soon. Like they're just going forever. Those numbers are getting bigger and bigger and bigger. So our job is to bring each circle, when it just gets off the screen, back to the other side of the screen. Just it right off the screen over here, waiting to come on again. And so that's where we use the if statement. We can say, hey, if a certain condition happens, run this line of code, which is the teleporting line of code. So I'll show you what an if statement looks like. Here they are. And maybe we can just take a look at x1 for a second. I'll just have one mountain here. Where are we here? I'll just use x1 as an example. So let's just watch this single mountain. Oh, I screwed up. I probably commented out too little or too much. Here we go. So here's my one mountain here. It's coming off of the side. It came off of the left-hand side. It's going across, going up by 2 each time. It's going to go all the way off the screen, and then it's going to teleport back to this side, all the way off the screen, and then come back on. Each one of those circles is actually doing the exact same thing. It's waiting till it gets off the screen, and then it teleports over here. So I guess there's 2 questions. How do you know it's gone off the screen? Like what kind of measurement can you do, and how do you teleport it? So the first answer is to the question, how do you know it's gone off the screen? Well, you can check the variable. You can check and see what is the value of the variable when it goes all the way off. So last class we drew a diagram. We actually projected the screen onto the whiteboard and we kind of separated into coordinates. And I realized I probably should just draw that with a sketch. And I wrote that down on a note, but I guess I never did that. But anyways, the story is that this is 800 over here. And our circles are 400 wide. And so we kind of figured out the calculations based on that information. So what is going to be the center of the circle when it goes all the way off the screen? Basically, the answer was it has to go a radius length off of the screen, off of the edge of the screen, and then you know it's gone. Because we're measuring the x from the center of the circle. So when this is off, like if you just kind of track it, like when it gets to that point right there, wherever x has gone a radius length beyond the edge of the screen, that's when we can teleport it. And so that's where the if statement comes in. Check out the if statement. Here it is. There's a bunch of them, but I'll just try and focus in on this one. You can ask a question that's true or false. And so I'm asking the question, is x1 greater or equal to, that's what the greater or equal to sign is in processing, 1,000. Why is it 1,000? Well, my radius is 200 because it's 400 wide and 400 tall. So there's a radius of 200. My screen is 800 wide, so I just add a radius length onto the edge of the screen. And if my x coordinate gets to 1,000, then I know that my circle has gone completely off the screen. Hey, why isn't 800? Does anyone wonder that? Have you ever kind of like gone, hey, wait, I think 800 would do it? Because my size is 800. It's 800 wide. What's wrong with, where did my if go? What's wrong with 800? Isn't that off the side of the screen? If I run it, we'll see what happens. If we go to where 800 is, remember, x1 is the center of the circle. So when the center of the circle gets to 800, that's right here. And that's when we teleport it. But did that look good? No, it just disappeared. Like the mountain had some sort of teleport spell cast upon it by a wizard. Like that's just not how animation works. So that's why we don't use 800. We got to go another 200 more, another radius length more to get off the screen. So that's why we do 1,000. You might also want to remember that we're not doing greater than. We're doing greater than or equal to because sometimes, depending on the number we're adding, we might not get to exactly 1,000. In this case, we will because we're adding 2. And if you started at 200 or 600, like adding 2 will get you to 1,000. But if you added 3, you wouldn't get to exactly 1,000. So we just say greater or equal to in case it gets to 1,001 because we're adding 3 or something like that. So that's the story. So that's the answer to question 1. The first question was, how do we know it's gone off the screen? The answer to question 2, how do we get it to the other side of the screen, is we just set x to a radius length off of the right-hand side of the screen. So we subtract 200 from the right-hand side of the screen, or sorry, the left-hand side of the screen. Oh, I can't keep left and right straight, apparently. We're going to subtract 200 off the left-hand side of the screen is what I meant to say. And that is where x is 0. So 0 minus 200 gives us negative 200. So that's why we teleport it to negative 200. And you'll see it is lovely. It comes right onto the edge of the screen, and it looks good. Again, you might think, why not 0? And we'll have the exact opposite problem as what we had before. If we do 0, we'll watch it glide across the screen majestically. We're doing greater than 1,000, so it'll nicely go off the screen. And then it's going to come back to 0, and poof, it just appears. And that spoils the illusion, right? That's not what we want. We want it to appear like it was just another mountain ready to come along. So that's why we can't use 0. 0 actually puts it half on screen because we're measuring from the center of the circle. So it's not 0, it's a radius length off. When you guys go to do your next row of circles, your radius is going to change. So you got to keep that in mind as to when you're like organizing your new animation, how is it that you're going to sort of make these circles like know when they're going off screen, where am I going to teleport them to come back on screen. Keep that all in mind. All these calculations are the same type of calculations for your next row of mountains. And then, of course, I just end up drawing 3 of them. What's the difference between those 3 mountains? I mean, let's look at the code. I'll bring all the code in now for those 3 mountains. I'll bring it all in. Here's my if statements. And here's my increasing them. my moving code. And then here's my circles right here. I'll bring them all the circles back. So take a look at my 3 circles. They look awfully similar, don't they? All 3 hills are using almost the exact same code. The only thing different is they're using each a different variable. Otherwise, pretty much the same thing. If you look at their movement code, it's all the same. It's just for a different variable, right? And then their if statements are also all the same. Look at that, they're the same. X1, X2, X3. So how is it that my mountains are in different places? I think that's the big question. If all these things are coded the same, how are they in different places? And the answer is because their initial values started in different places. X1, X2, and X3 are just set to start at different places. And so they still have the same if statement. They're still going to teleport when they go off screen. They're still going to teleport to the same place. They're all going to move at the same speed. They're all the same size. So much of that code is identical over and over and over again. The biggest difference you have to remember is making them start in different places. There it is. I don't know how clear that was or how well that was received. So please ask a question. Anybody have a question right off the bat they'd like to ask? No, not right now? Okay, so what we'll do is I will back off from talking. I'll close this video so we can upload it for prosperity and for future generations to enjoy. And then I'll just come around and do kind of some one-on-one help stuff. So you might just be stuck with a little bit of a thing. Oh, actually, maybe before I go, I'll just mention a couple of pitfalls that you can have with if statements, especially. Check out these if statements. Here's pitfall number 1. Pitfall number 1 is you put a semicolon here. No semicolons allowed in an if statement. Technically, they are allowed, but they ruin it. So don't put any semicolons along the if statement. That's not where a semicolon goes. There's pretty much only 2 things that can end a line. Either you end a line in an open brace or a semicolon, and never both. So keep that in mind as you're programming. If you ended it with an open brace, don't put a semicolon. If you end it with a semicolon, don't use an open brace. What do these braces mean, by the way? What are these braces here for? What do they indicate? Anyone want to give it a stab? An attempt? No? Not sure? Well, I'm so glad I asked the question. So the braces are basically saying, starting here and ending here, this is the code that will happen if this condition is true. So if this condition is not true, this code does not happen between the braces. If this condition is true, then all the code between the braces will happen. Right now, there's just one line of code. But you could have many lines of code that would either happen or not happen based on that condition. So all the code between the braces is connected to the condition now. That's what those braces are for. How do you guys feel about that? Does that make sense? I don't know. I feel like I have a wall. It's a one-way mirror. So you guys can see me, but I can't see you. So I'm giving out some instructions, but I can't tell if I think some people are dutifully doing something else, which is good. But the people who are sort of like tuning in to be like, yeah, what's happening here? I'm not too sure. I can't tell if this is making more sense or less sense. So I have no feedback here. So help me out. Is this making sense? But anybody feel like it's not making sense? That's more important for me to know. If someone's like out there going, yeah, I'm not too sure. Anybody? No? Okay. So that's what braces are always about. When you open a new brace, it's like making a block of code. And this is the block of code that is either happening or not happening based on that if statement. So first thing, don't put semicolons there. Second thing, whoa, you could forget to close your braces. Watch what happens. If I forget to close my brace, here's a classic thing. I'm programming away, and I just, I'm going to close my brace. Here we go. I close my brace. I go to run it, and it says, whoa, found one too many characters, open brace characters, without a match to it. Has that happened to you? It's going to happen to you if it hasn't happened yet. The story is that you got to close all your braces. So actually, this if statement is closed, and this one's closed, and this one's closed. So what isn't closed? Well, don't forget that your draw function also has braces. So you got to make sure your draw function is also closing. So there's a brace for your draw function, and you got to make sure that one closes as well. So at the end, I actually have two braces here. There's the brace for the if statement and a brace for the draw function. And the braces for the draw function, that's just saying everything between the open and closed brace of the draw function, that's what happens over and over and over again. That's what we're drawing to the screen, and every 60 frames, like drawing it over and over again. So that's what those braces are for as well. So lots of things to make mistakes on. And that's okay, by the way, to make these mistakes. It's part of your practice. Just like when I began my basketball career, I picked up that amazing basketball and I shot it and I missed. And you're going to miss too. And if you keep at it, unlike I did with basketball, I just didn't continue with basketball and I really failed at doing that. But you're not going to give up. You're going to keep going with it too and expect to make mistakes and expect to ask questions. Don't expect to just be slam dunking it from day one. You're going to need to ask questions, okay? So I will stop it there. I guess I'll just mention that also I have some ground. Where's my ground? Here it is. I'm just putting a rectangle over the bottom of the hills to kind of create that illusion there. Woohoo! And then I also have a bunch of mountains here for the foreground. And that's sort of the next step after you get that going on. Here's my cloud. I won't talk about that too much right now. We'll come back to that later. And so this is what we're aiming to have. If we can get that by the end of class, that would be fantastic, actually. But I'll come around and answer questions now. I'll just stop my video. Thank you so much for your questions.